Hello, this is Mr. Rasmussen with Algebra 2, lesson 99. All right, in this one here, we look at when we put an absolute value into our graphing of our inequalities, what that looks like when we put that onto a number line. At the beginning here, they show you that if you put out a number line, 0, 1, 1, 2, 3, negative 1, negative 2, negative 3. Absolute value just simply means how far is it from 0. So the absolute value over here, 1, 2, 3. Over here, there's no negative, it's just how far away. It's 1 space, 2 space, 3 space, which distances are always positive. That's what they're showing you there. Okay, so let's say that we'll go with example 1. Example 1 here. They give us the absolute value of x is anything less than or equal to 4, and our domain is integers. Okay, so if you think about this, any number we put in here is going to turn to positive. So what number is actually equal to or less than 4? Well, 5 wouldn't work because it's larger than 4. It has to be less than or equal to. So the first number that's equal to it is 4 and 3. And less than is 3 and less than is 2. The domain is integers, so it's only whole numbers. But then think about it as we keep going. Is 0 less than 4? Yes. Is negative 1? If you put a negative 1 inside the absolute value, it becomes 1. And is 1 less than 4? Yes. So negative 2 comes 2, that's less. Negative 3 becomes 3, that's less. Negative 4 becomes 4, that's less. Negative 5 in an absolute value becomes 5, and that's not less than 4. So we'll see that on our graph here. The way we would do this is first just write it out as is. So we're going to graph x is anything less than or equal to 4. And then also we're going to write the opposite there. X is anything, we're going to put a negative 4 here, equal to or larger, and since we have a negative, we're going to flip the sign. So let's graph both of those. If we do this here, x is anything less than or equal to 4. Here's 4 on our graph. We'll put a solid circle there, equal to. And over here, x is anything greater than or equal to negative 4. So negative 4, we'll put that there. And then it includes everything to 1, 0, 1, 2, 3, negative, negative, negative. It's going to include everything in the middle, so you'd fill it out like that. All right, a little tricky, but spend some time just thinking through what numbers actually work inside there. All right, example 2 is negative absolute value of x plus 3 is greater than 0. Once again, our domain is integers. Okay, so for this one, we got to get x by itself first. So let's, just like as if this was an equal sign, let's subtract 3 from both sides. Okay, so now we have negative absolute value of x is greater than negative 3. Then we're going to divide by a negative 1 to cancel out the negative here. So remember that flips this sign and then changes that one. So the absolute value of x is anything less than 3. All right, so then we're going to graph that, just x is less than 3. And then we're also going to flip this one and graph that x is anything greater than negative 3. So how would that look on our number line? Well, here's our positive 3, here's our negative 3. It doesn't include those, see, no equal sign. So actually, we'd put a solid circle because it's integers, no bar line. Solid circle on 2, solid circle on negative 2, and then we'll include negative 1, 0, and 1. Everything in between these two numbers. Okay, example 3. We have negative absolute value of x plus 2 is less than negative 2. Our domain is reals. Okay, so once again, we've got to get x by itself. Let's subtract a 2 from both sides of our inequality. Cancels here, we get negative 4 here. So absolute value, all All right, so negative absolute value of x is less than negative 4. Let's divide by a negative 1 on both sides. That's going to flip my sign, so I have absolute value of x is greater than, and that becomes 4 because negative times divided by a negative. Okay, once again, I'm just going to write this without the absolute value. X is greater than 4, but then x is also, flip my sign, less than negative 4. Okay, so let's put that on a number line here. Here's my 0. We're going to work on the high end. Here's 4. It doesn't equal it, but we'll do an open circle and it says x is anything greater, so a bar and a line arrow going that way. Over here, negative 4, open circle, line going this way because it's anything less than that. So in this scenario, if you put in negative 6 would become 6, and then as the absolute value is removed, okay, and then it would be become a negative 6 again because this went outside, so negative 6 plus 2 would be negative 4, and negative 4 is less than negative 2. You can see how that works. However, if you use a positive 7, put a positive 7 in there, positive 7 doesn't change absolute value, then becomes a negative, and negative 7 plus 2 is negative 5, and that's still less than. So you see how that works there. Okay, let's look, moving on here. As you look on the top of page 394, it makes a statement, there are no absolute values that are less than 0. So in this scenario where you have absolute value of x is less than negative 3, there's no number you can put in there that works. Like if you put a 4 in there, 4 is not less than, this is always going to be a positive number because the absolute value, and there's no positive number that's less than this negative number. So that one doesn't work. And then in like fashion, if we do x is anything greater than negative 3, well, because these are positive numbers, every positive number is greater than 3, so that would be all of them. Okay, so they demonstrate that in example 4, so let's look at that. All right, example 4 here. We're given absolute value of x is anything less than negative 2. The domain is all reals. Okay, so in this case here, we would just write it out. X is anything less than negative 2. Or x is anything greater than positive 2. Well, that doesn't work. Anyway, x is anything less than negative 2. Well, because it's always going to be positive, there's no positive number, so that one actually you'd write that out as a null set, or you could put an empty set, which just looks this way there, as an answer to that one. No numbers in absolute value that are less than a negative number. All right, also inside of example 4, they give us absolute value of x is greater than negative 2. Domain is all reals once again. So in this case, every positive number is greater than that. So you would just do a solid line there. 0, you just do a solid, your line showing that it goes infinitely all directions. All of them are part of it. All right, let's look at example 5. Negative absolute value of x minus 5 is greater than negative 3. Domain is back to integers, just the whole numbers. Okay, we gotta get this x by itself, so let's add 5 to both sides. Once we do that, we get negative absolute value of x is greater than 2. We're going to divide both sides by a negative 1. Cancels it here. This we get absolute value of x is less than, we get a negative 2. That looks the same as that. That is not graphable. There's no solution to that. So once again, empty set. Okay, that being said, go ahead and try the practice problem. And I will do that here, and then you can check your work with my work. So, we have negative absolute value of x plus 3 is less than a negative 2, and my domain is integers. All right, let's get the same as an equal sign. Let's get x by itself, so subtract 3 from both sides. Negative absolute value of x is less than negative 5. Divide by a negative, divide by a negative. Absolute value of x is greater than 5. Okay, and so once I get there, right, x is greater than 5, and then same thing, x, I'm going to flip my sign and make that a negative to show the other side of it. So basically, I'm going to have, well, 5 is not included. If I put 5, well, let's put 5 here. 5 is not included, and since it's just integers, there's no reason to put an open circle. I mean, there's no point. So we're going to start, our first number that shows up here is 6, and it's anything greater than the 6. So we could go 7 and an arrow going this way. And then same thing over here, negative 5 is not included. The first number that shows up would be negative 6 with a solid circle, negative 7, solid circle, and an arrow going that way to show that all the numbers smaller than negative, including negative 6 and smaller, are a part of it, and all the numbers 6 and greater are a part of it. Let's throw something in there to try it. Let's put 10 in there. If we put 10 into here, it becomes negative. Negative 10 plus 3 is negative 7. Is that smaller than negative 2? Yes. Let's put in a negative 10. Well, if you put a negative 10 in the absolute value, it just becomes a positive 10, and you're right back where we just did that. Okay, hope this makes sense to you, and you can work through that. Feel free to text me if you'd like some extra help, and have a great day.